we're going to start off talking about the atmosphere. This is a really important topic for us in aviation meteorology because, as we will see in our study of the atmosphere of the Earth has a huge amount to deal with in weather and how weather actually happens. Now, think about movies that you've seen where someone's in space, and they always are wearing a spacesuit if they're in space. I am a science fiction movie fan. I like movies like The Martian, 2001: A Space Odyssey, Star Wars series. And if you think about it, we can live without food for weeks at a time. Humans can live a long time without eating. You can live without water for a few days. Not as long as food, but you cannot live without an atmosphere for more than a few seconds. So it's really, really important that we think about our planet's atmosphere. Some ways that we're going to describe our atmosphere are two ways. We have weather, and then we have climate. Now, if we think about this is going to be covered on exams that you will have in the future, so make sure you understand this material. But an example of weather could be described as just a snapshot. So the current visibility at the airport is 7 miles visibility. That would be seen as weather. The average temperature over the whole month of December in Wisconsin, that would be an example of climate. A report that tells us the predominant wind direction in Dallas, Texas, that would be climate. Or a prediction on where a hurricane is going to make landfall. That's more like a prediction, right? Or we say a record of what the current precipitation falling outside is. That would be weather. So weather takes a snapshot of what's going on in the atmosphere. Climate takes an average of what's going on. So what are some other elements of weather? Well, we have other things like precipitation, which I mentioned, humidity, how much water's in the air, temperature, the cloud height. So if we wanted to make a report of the current cloud height, if I looked outside, that would fall under which weather or climate? And the right answer is weather. Wind direction. These are some examples of how we can describe the atmosphere. So be familiar with weather versus climate as you continue in your studies. Be familiar with examples, know how to tell if it's weather or how to tell if it's climate. All right, let's start by talking briefly about kinetic energy. So, kinetic energy is important to us in the study of temperature because kinetic energy is just used as a measure of temperature. So, temperature is a measure of how much kinetic energy of molecules within something we are measuring. Picture a gym full of kids running around or jumping around at a trampoline park maybe. They are full of kinetic energy. They're bouncing all over the place. This is like hot air. It's full of a lot of molecules bouncing around. Has a lot of kinetic energy. Now, if you picture a group of students, which I sometimes have at 7 a.m., they haven't drunk any coffee yet. They are just sitting there in their seats, falling asleep. This is cold air. It doesn't have much kinetic energy. It is just sitting around. Okay? In another application from aviation, if you think about the brakes of your aircraft, as you roll the airplane to a stop using the brakes are going to take kinetic energy and actually turn it into heat. So the airplane has kinetic energy as it rolls down the runway. The brakes squeeze the brake pads. These brake pads get hot, and it turns it into an increased temperature of the actual brake system. So temperature is just a measure of kinetic energy of molecules within something being measured. And you need to be aware of that definition of kinetic energy. Now, the primary scale that we use to study and look at temperature is Celsius for aviation. As a general rule, we're going to use Celsius. There are a few weather products, which we will eventually cover in this class, that do use Fahrenheit, but predominantly aviation around the world uses Celsius. You will see these report temperatures and dew points in Celsius on ATIS reports as you listen to the weather before your flight, or as you read a METAR report. All of these things we're going to talk about as we get there in the class. Some charts do use Fahrenheit scale. So here's a comparison of the different temperature scales. So we have Fahrenheit, we have temperature in Celsius in the middle, and then we've got Kelvin. So if you will note over here on the Kelvin scale, 0 degrees Kelvin, absolute zero, negative 273 degrees Celsius, that's where all energy is going to stop. So at 0 degrees Kelvin, we don't have any more kinetic energy moving around. All molecular motion is going to stop at this point. But be familiar with the temperature scales and realizing that Kelvin is not what we use, Fahrenheit is not what we use, Celsius is what we use in aviation. Okay, so now that we've talked a little bit about temperature being a measure of kinetic energy, let's talk about heat. So heat is going to be transferring kinetic energy from one mass to another. Okay, as an example, you get out of the shower in the morning, you feel warm from the nice warm shower, hopefully. And as you are toweling off, you're standing there, just got out of the warm shower, just shut off the water, kinetic energy is going to transfer as little water grains evaporate off of your skin and you start to feel cooler. For a matter of fact, it takes 600 calories to evaporate 1 gram of water at room temperature. So if we look at my diagram here, we have something that is warm, it loses its kinetic energy, it's going to change to something cold. So the transfer of kinetic energy from one mass to another is heat. As we transfer heat, that is the transfer of kinetic energy from one mass over to another. So be familiar with that transfer of kinetic energy, what that is. And we are going to stop with that. We're going to continue on the next video with heat transfer in the atmosphere. Make sure you complete the assignment to answer questions about the first bank, and then continue with watching the next video.